if we have here again quotient on x and y, suppose we have here vector A moving in this direction, and then we have another vector B moving in this direction. Therefore, the sum of this vector, which is called resultant vector, must be a line that connects the origin to the head of the last vector. This is our resultant vector. Now, to get this one, to get the magnitude and direction of R, R, we need to use this equation. So if you could still remember, Pythagorean theorem is um, c squared equals to a squared plus b squared over square root of a squared plus b squared. Now in physics, we're going to apply this one, and this is very useful, especially if we have more than one or three um, vectors. So we would say the resultant vector, the magnitude of the resultant vector, is equal to the sum of x squared plus the sum of y squared. So this is how we solve for the magnitude of the resultant vector. This is in 2D. For 3D, this will become summation of x squared plus summation of y squared plus summation of z squared. Okay, this is for 2D, this is for 3D. On the other hand, in finding the direction of the resultant vector, we have to use tangent angle y over x. But since we expect adding multiple vectors, so this will become tangent angle summation of y over summation of x. Okay, absolute value. And therefore, finding the direction must be tangent -1 of summation of y or summation, absolute summation of x and y. This will be our equation solving for the direction of the resultant vector. Now we talk so much about resultant vector, but what is really a resultant vector? Resultant vector represents the individual vector. By looking at the resultant vector, you would know at what particular direction where most of these vectors are going.